Alright, welcome everyone, and welcome to Microservices for Mortals. And even after there's been many talks about microservices at this conference already, I take it you're still microservices curious and not microservices tired already, so I consider that a good thing. So let's start. So a little bit about my own background. I work as a fellow at a company called Luminis in the Netherlands, and I have a background in Java since '95, so I've been around for about 20 years, doing all sorts of architecting and developing systems all over the place. So I think I know a thing or two about Java, and the things that I learn, I like to share them as well. So, quick question here. Who of you likes Metallica? Please raise your hands. Okay, that's good. The reason why I'm asking is that on the way to the airport, I was listening to one of their songs, and then suddenly it struck me that there was a bit of truth in there which I could apply to the beginning of this presentation. So actually this is the first time that I'll start my presentation with a quote from Metallica. So that's why I was asking. So this is from a song called No Leaf Clover. I don't know if you know it, but it's just something about the soothing light at the end of the tunnel. And I think that for some, microservices are the soothing light at the end of the tunnel. And some of the companies out there are able to make it work. And they are looking for a way out of their current architectural mess, maybe, and they look at microservices and they know how to make it work, or they try to make it work, and it will turn into something beautiful. For others, the soothing light at the end of the tunnel might appear to be a freight train coming their way, and that's exactly what I will be talking about for the next 45 to 50 minutes. Right? So I'll try to have you recognize the freight train, and I'll have you avoid the freight train coming your way. So that's my goal. So I want to start by talking a little bit about Italian food. And the reason that I'm doing it is because at some point we are, comparing our architectural styles to Italian dishes, right? So basically it comes down to this. So everything before service-oriented architecture, we called it spaghetti architecture, right? Because it was a mess. And then at some point, say halfway to 2000s or something, apparently we ate all the spaghetti. And we started doing SOA and stuff, and we realized that we turned the spaghetti into lasagna because of all the layering that you have in SOA. And now that we're on the brink of the next big architectural shift, it is about time to assign an Italian dish to microservices. So, need a little bit of help here. I offer you two choices. On the left-hand side we have macaroni architecture. Anyone in favor for macaroni architecture for microservices? See a couple hands. On the right-hand side, I have a ravioli architecture, right? All right, a couple more hands, and a couple of you are still undecided, or you fell asleep already. Okay, so in order to solve this debate, or to convince all of you who raised your hand for ravioli architecture, I'm going to show you a picture. So for every presentation that I do a bit of, Google research. I mean, that's what you're supposed to do, right? So at some point, I stumbled upon this picture, and you might recognize it. This is actually one of Netflix's architectural diagrams, right? So this is their microservices architecture after a while. So it's beautiful, right? I mean, it sounds like an amazing architecture. But if you stare at this picture for a couple seconds, right? So do it. You stare at the picture for a couple seconds. You suddenly start to see this. And this, well, it's not exactly macaroni. I mean, this is actually the American version of macaroni. It's called mac and cheese, right? So you take a beautiful Italian dish, and then you dump a shitload of cheese on it, and then you have mac and cheese, right? And I mean, it screams healthy, right? You see all the vegetables and stuff in there. So from now on, I want you to think about microservices as mac and cheese architecture, right? Because that's exactly what it is. So okay, so that brings us to the next question. Which not this. But which is, where did this whole style of architecture actually originate from? And more serious now. So I think with a lot of things like we've seen in the past, like SOA or NoSQL or Ajax or a number of other styles, I think people have been doing a number of practices, a little bit of process, have been using some tools and techniques for a while, and then after a while it gets a name, right? But there's a big chance that even if you're not doing microservices, you might still be doing some of the practices, or you might still be interested in some of the technologies which comes along with it, but you're probably not doing micro, or you're not naming it that way. So the microservices style of architecture originated from companies like Netflix and Amazon and a couple of others, right? So these two are considered to be the poster children for the microservices movement. Now, microservices is not there's not like an absolute truth in the microservice architecture. There's not even a formal definition, right? So I'd like to talk about microservices as an architectural style, which is still relatively young, and it's just a collection of processes, tools, techniques, which are out there. And the reason that Netflix and Amazon and others turned to this style of architecture is because they needed to overhaul their existing business model, or they wanted to create something completely different. So in the case of Amazon, it was a new way of actually redefining online e-commerce, right? And what they say that at some pages in the Amazon e-commerce shop, right, there's more than 100 microservices behind the page doing the actual work, right? So it's a way of redefining e-commerce for them. It's adopting their business model to a revolutionary e-commerce approach, for which they turn to this style of architecture. Now with Netflix, it was something different. I mean, they used to be a DVD selling or DVD renting company, right? Renting you or selling you physical stuff that they would send to you. And then they completely overhauled their business model, and they turned into, well, one of the biggest online entertainment sites available, right? So they took different approaches, and then this style originated. Now, for both of them, it was not so much about the process, it was not so much about the technology that they use, but it was about addressing the evolving spectrum of their architecture. So it was addressing business agility, actually, right? So adopting the business model. And since they were using services themselves, say cloud services or APIs, whatever you want to call them, it made sense to just keep on stacking those APIs or keep on stacking those services. And that's how the architectural style originated. Now, you could also say that some things have a natural attraction towards microservices. So maybe if you're doing DevOps right now, right, then the next step of doing DevOps would be ending up with some sort of a microservices style of architecture. Right? So empowering your teams to be fully responsible for the idea, developing of the software, putting it into production and maintaining it there, and maybe also removing it from production at some point, right? That's what DevOps is about, and it's an absolute requirement for doing microservices. So you can turn it the other way around as well. If you are not doing DevOps right now, and you are thinking about going to a microservices style architecture, forget about it, right? First, get your DevOps in place. If you don't have your DevOps, you will never succeed in having a microservices style of architecture. So it's an absolute requirement. Another reason for turning towards this style is maybe the need to scale your people and your teams and have multiple teams and multiple people work at stuff which is in production in your landscape at the same time and change stuff at the same time. If you change something here without breaking stuff all over the place, right? So if you're looking for a way to do that, then microservices might prove to be really useful. And then from a completely different viewpoint, I think this goes for Netflix, for example, since there's a whole lot of technology revolution going on sometimes, right? So for example, client-side revolution with new devices, or moving away from stateful server-side content to stateless servers, and lots of stuff happening on the client, right? It is about adapting to changes, adapting to new stuff in a very rapid fashion. And that's what made the whole microservices style really attractive. But the bottom line is, and you should remember that microservices are truly about business agility. And that differentiates them from other approaches, right? Now, if you start reading about microservices, you will quickly run into quotes like this. Microservices are like service-oriented architecture, but then only the good parts, right? So this makes you wonder, what actually are the good parts of SOA, right? Well, I think you could say the whole idea of services, that's actually one of the good things about it. And I think some of the architectural patterns that came along with SOA are actually not that bad. But somehow along the way, something happened to SOA that made us, well, unlike it at some point, right? So the question is, what happened to SOA? I want to express a little warning here. This is not my most politically correct slide. So no pictures, please. I mean, in every slide deck, there's one slide that you should remember. This is probably not the one. But, well, allow me to explain. So I think it's all Gartner's fault, right? So Gartner messed up SOA completely. Because when SOA got popular, you know, you have these CEOs and these CIOs and CTOs, and they go once or twice a year, they go to these Gartner conferences. And the Gartner analysts, they were talking about this architectural style. And they were actually selling it to them, but then selling in a good way, right? I said no pictures. And so during this Gartner summits, it's not only the CTOs and the CEOs who are there, and they really wanted to believe this story of services all over the place and reuse and everything and SOA utopia and what have you. But there's also vendors coming to these conferences. And so when the CEO said, wow, I want to have this SOA, where can I buy it? That's where the vendor stepped in. And they said, well, you know, let me take this beautiful pattern called an ESB, and let me turn it into a product and sell it to you for an insane amount of money, right? And then, when your CTO was completely bought in, when they bought this expensive ESB thing, they brought it back to you. And now you had to work with that tool, and that insane piece of software, right? And then make their dream a reality. And that, for some reason, never really worked out, right? So I think that's what happened to SOA. The trouble is, history tends to repeat itself. So out there, somewhere in the shadows, there is the vendors lurking, right? And they're watching this microservices movement, and they say, okay, so at what point can we step in and can we make money out of it? Now, once again, when I was doing my Google research, I stumbled upon this, right? So this is actually a kind of a reference architecture for microservices, you want to call it like this, and there's not so much wrong with this diagram, apart from a little typo here and there. But lo and behold, in the lower right-hand corner of the screen, yes, exactly. So Gartner is talking about microservices now, right? And well, there's interesting pieces in this diagram that I will explain further down the line in the presentation. But since Gartner is talking about this, and your CTOs and CEOs will gather for their next summit, and the vendors will be there as well, I think history will start to repeat itself. And I think it will maybe take about 3 to 6 months before we see the first products coming out labeled microservices fabric or what have you, right? So beware of the vendors, because they will step in and they will try and monetize it. And now, in the words of a famous movie quote, or actually it's not a movie, it's a documentary, right? That's the sound of inevitability. All right, so now that we are, you know, at the point in the presentation where we talk about the matrix, right? Let's get the most important question from the matrix and say, well, when it comes to microservices, which pill are you willing to take? And, well, I take it you've all seen this documentary, so you know which way it will go. So, but just for a minute here, let's pretend we take the blue pill, right? Otherwise it will mess up the slides. So let's say we take the blue pill. So the blue pill is about, you know, blissful ignorance, right? It's about reading the latest blogs and reading all the stuff that passes by on Twitter and what have you. And it's all about, you know, Docker this and Kubernetes that, and microservices are, you know, completely awesome. So at some point you might think, why am I the only one who is still stuck with this old crap, right? So why is everybody doing microservices and it seems to be really successful, and, you know, I'm not doing it. So what am I missing here, right? And if you go head first into this, it will not only take you into blue pill world, but it will definitely take you to the next world of pills, which is probably Vicodin world. Because if technology is your main driver, if new technology is going to be your main driver, then you will end up with a headache when you go the microservices way of, you know, insane proportions. So blue pill is not the way to go here. So let's step back and, you know, apologize to Mr. Morpheus here and say, well, there was a speaker dinner last night and I had a couple beers too many, right? So I took the wrong choice here, and yeah, so I took this blue pill, and, you know, blue pill lived up to its reputation. It gave me the microservices boner for a while, but yeah, maybe I am the one So let's try the other one. Let's try the red pill. And the red pill, as we know, is the pill that takes us to the painful truth of reality, right? And let us see things from another perspective. And what it actually is in terms of microservices, it's making us think about defying the laws of IT physics. And what that will mean, I will try and explain it on the next slide. But the first thing that you have to realize when you enter the world of microservices is that this thing is about distributed computing. And distributed computing is still very hard to do. Not because it is hard to get the resources or actually use it, but it's hard because it's hard to wrap your head around, right? It's still hard to wrap your head around. And the next thing is that this whole microservices style will quickly get you from a synchronous programming model into asynchronous programming models. This is also not the first time that we try and do it, but this is also something which is hard to grasp. Because I'm sure that there are developers out there, probably not us, but others, who are willing to admit that they have a hard time wrapping their head around asynchronous programming models, right? So I read a quote once that said, there's nothing wrong with asynchronous programming except for programmers. And I think it holds the truth, right? So then there's a number of other gotchas, which I will go into, and which explains defying the laws of physics. So at some point in the documentary, they talk about the spoon, right? And that there is no such thing as a spoon. And if you think about the spoon in terms of microservices, then the spoon in microservices style of architecture are the things which I listed here on the slide. And you could argue, of course, whether they are good or bad things, but they're probably things that you are used to in having in a non-microservices style of architecture. And maybe they are things that you learned to use when developing software, or they are very important things in your current architectural model. And you have to realize that as soon as you enter microservices world, there is no spoon. So these things are probably not there. And even if you think you see them, they are probably not there, right? So say goodbye to most of the things which are on the slide over here and a number of other things that I haven't even listed. And if you're willing to accept that, then you are ready to enter Red Pill world. And this is what Red Pill world is all about. Like I said, it's about defying the laws of physics. And I've been doing this talk for a little while, so keep on watching this clip, and I hope at one point he falls off, but spoiler alert, that won't happen. Okay, so yeah, so it's about time. You're all proven to be mortals by coming to this talk, so let's do a round of Mortal Kombat, right? And just before we can, enter the arena, let's do one step back and pick our fighter. So, okay, fighter select screen. There's a couple of interesting figures over here, and I'd like to try all of them. But for now, I'll stick to the one in the lower left-hand corner. Let's look who he is. It's the Monolith, right? So when you start reading about microservices, you start reading about monoliths. And when I first started, reading about monoliths, it rang a bell because I knew about monoliths as the way to describe the architecture of the old mainframe, right? But nowadays, it appears that everything that we have been doing up until now has yielded nothing but monoliths, right? And if you read a little bit further, it seems that the word monolith has a very negative meaning, has a very negative connotation to it, right? You can't be proud if you're a monolith, right? Or at least that's what they make you believe. So just to state the obvious here, I would not say that all non-microservices applications are bad applications per se, right? They try and make you believe it, but that's not entirely true. So one of the questions or one of the debates that I often run into when I talk about this with customers or with coworkers is, I ask them, well, what do you call an application which everybody wants to interact with, but which was not designed to do so in the first place, right? So is it a monolith? Or is it just a successful application, right? And, think about it. Now, and also maybe let's do a little sidestep here. If we think about this from a user perspective, I mean, a user really doesn't care, right? I mean, this is kind of like the ultimate user story that I run into at many customers. And users don't care whether you build a monolith or microservices, right? They just want the thing to work. So, yeah, even if you're building a modern web application, but you're not using microservices, keep on doing it. I mean, there's nothing wrong with building monoliths. But when we talk about monoliths in the negative way, with a negative connotation, I mean, we're mostly talking about systems that have been building up massive amounts of technical debts, and we've probably all been there, right? At least I know I have. And if you start to build up massive technical debt, things become harder to change, stuff will break, right? If you change something here, other things will break. And well, there are a number of signs that your monolith is a monolith in the negative sense, especially when it comes to your QA cycles taking lots of time. So for example, I used to do some work with a customer where they do agile and they have 2-week sprints. And then when we deliver software at the end of a 2-week sprint, they go into a 6-week QA cycle, right? I mean, that's a sign that somewhere along the line, the monolith went sour, right? All right, so recently, or maybe not that recent, but there was some talk about this whole monolith to microservices approach, right? So there's actually 2 ways how you can start to do microservices. There's either you start with a green field, right? Some people have the luxury. Other people have to start from an existing application. And recent train of thoughts is, well, build the monolith first, and then at some point you start to strangle off some services from that monolith, and you make them separate services in your landscape, and that's how your microservices architecture will take off. Now, I think this makes good theory, but in practice it's actually pretty hard to do, because strangling off these services requires you to rethink some of the essential ingredients of those services. For example, how do they communicate with each other, and what's the interaction pattern that you have with these services? And they probably weren't meant to be set apart when they were built as part of the monolith. So it will give you a number of struggles. So let's dive into a number of these struggles that you will run into. And I think apart from these struggles being valid for the monolith to microservices approach, I think they're also pretty much all of them are valid when you do greenfield microservices development as well. So there's a number of them, and I'll walk through them. So let's start with something that I like to call initial investment. So initial investment is something that you need to do when you want to start with a microservices style of architecture. In some of the architectural diagrams which are out there, it's also called outer architecture. So it's not concerning your services per se, but it's everything that you need to have in place in order for services to really work together. So think about service discovery, things like logging, metrics, and analytics and stuff like that. Now, this is probably the easiest part of doing microservices, because for most of these concerns, most of these cross-cutting concerns, there's probably frameworks and tools out there that you can just download, install, configure, and you're done with that part of your outer architecture, right? Some consider a little bit more work, especially if you want to have them fault tolerant, right? But this basically is the easiest part of getting started. Then the next thing that you need to have in place, and we already discussed it, is that you need to have your solid CI/CD practices. You need to have your DevOps in place. I just want to stress it again. If you don't have your DevOps process in place right now, don't even think about starting to do microservices, right? Get your DevOps in place first. And in some organizations, just getting DevOps in place will take months, if not years, to do it correctly, right? Just like with Agile, it does not only require a change in your tool sets or a change of working with other people, but it also requires an organizational change. And this just takes time, right? And then, last bullet of the slide, just a tiny bullet, but it's a very important topic. I mean, in the field, there is a huge impact on testing if you go into microservices, right? Instead of having a big application that you can run integration tests with, right? Right now you're scattering all the logic over the landscape, right? And you're changing services individually from other services. So testing them in production, right, is going to be a little bit of a challenge. And this is a subject that we can talk for hours. And I think later today there will be actually a talk on testing microservices. So I highly encourage you to go there as well, right? Now, if you've got the initial investment in place, right, and I mean, that's probably one of the easiest hurdles to take, you'll get into some of the next. And one that will definitely attract some people's attention is data strategy and microservices. So basically it comes down to this. There's two ways of doing your data strategy. There's the right way and another, right? So if you do data strategy the right way, it means that you don't have multiple microservices share the same database model and perform updates on it. The latter part is specifically important. So basically it means splitting up existing databases into smaller data stores, right? The reason for this is that if you don't do that, you get some unwanted coupling as a result. So if you couple everything at the database layer, there's a high chance that this database layer will then ripple through in your domain model, and then you have a domain model shared across multiple microservices, and that will get you into trouble pretty quickly, right? So cut up the database, and if you have an existing database and you have a DBA running around, right, this will get you to an interesting discussion, right? Especially if this DBA, give it its best shot and put the database, over the years in like the 35th normal form, right? It's pretty hard to cut it up into pieces for individual services, right? So there's a number of strategies that you can take. For example, you can say, well, let's start by separating out read and write access. And there's a number of interesting patterns that you can use, like a CQRS or event-driven style, right? To separate read and write streams at first, but then in the end, you will have to end up with separate data stores for each service, right? So not separate database service per se, but at least separate databases within the database server, right? So it sounds very simple if you put it on a slide, but it's actually pretty hard to do in production. And then a couple of questions arise. For example, one of the first questions that somebody will come up with, yeah, but we have this common data, right? How do I share this common data across services? Well, the answer is pretty simple. It's you don't. So if you have a couple of spare microseconds flying around when you have to do service calls, right? You just build a new microservice sharing that common data. That's one option. And if you don't, right, then you just copy the data. If you think about this, copying data, that sounds like redundancy, right? And redundancy is something that we've learned to avoid. So basically, in terms of red pill world, we're talking about a spoon here, right? So you have to unlearn some of the things that you've learned over time, right? You have to do things differently, even if they go against all of your, software engineering. Yeah, well, I don't know how to put it, right? It goes against everything you've learned over the years, and you have to unlearn it in order to do this the right way. Right? Same thing if you want to deal with referential integrity, right? So it's hard. You don't have it anymore, right? There is no thing as a shared domain model across services. So yeah, you don't have it. And if you really, really want it, well, you create another layer of abstraction by placing services on top of other services. But if you do this the wrong way, it will quickly get you into trouble. So unlearn things, spot the spoons, and learn how to deal with them. Now coming back to this strangling, right, this strangling of services from a monolith, as soon as you start doing this, you will run into issues. Because when the monolith was first designed, right, the components that you're now taking out of it maybe had a very chatty interface, right? So you really have to think about the interaction pattern with this piece of software. It's going to be fine-grained, it's going to be coarse-grained, right? What kind of data am I going to put into it? What kind of data do I expect to get out of it, right? And also rethink the communication protocol, because when this component was still inside the monolith, you probably did a very cheap in-process call, right? But now that you take it out, you have to deal with remoting. And with remoting comes stuff like serialization and latency and what have you. So you really have to rethink the communication protocol. So that brings me to the next slide, where I want to talk about service communication. Now, in most of the approaches towards microservices, you see that people try and standardize on a common communication protocol. And oftentimes they choose REST. And I don't think that there's a lot wrong with REST per se, but just bear in mind that there's other choices as well, right? So microservices and REST are not married per se, right? You see it being used a lot, but there's things to think about. For example, if you have to deal with massive fan-out, so you have one service calling a service calling multiple other services, right? Every service call, you need to build up a connection, right? You have the overhead of the protocols which you use, and you swap some data around. So is REST still fast enough in order to meet your performance requirements, right? So there's other things. There's alternatives, and I've listed a couple of them. One of the popular ones is, for example, WebSockets as an alternative means, right? Because it adds less overhead. And also you see people resort to, say, binary protocols. And I think there's a kind of a best practice emerging where you basically see that you have two communication protocols. So on services which are used from the front end, through an API gateway or not, doesn't really matter, you see a lot of REST happening, right? And then further down in the architecture, where you have services doing just massive fan-out calls internally, there's probably something like messaging, right? So that's mostly the two choices that people tend to standardize on. All right. Next topic. Avoid reuse traps. Now, at some point, when you start developing your services, someone will come up to you and say, well, I mean, we're now developing our third service, and I've been typing everything from scratch all the time, so isn't it time for the abstract microservices template framework generator, impl, whatever, right? And this is something which is common in the Java world for some reason, right? So for some reason we tend to suffer from, well, I like to call it abstraction disease for some reason, right? And sometimes you just look at a piece of code and you say, why on earth do I need to abstract this, right? So it's not just because typing the characters. So in microservices land, reuse traps are a big pitfall, right? So don't share code between services in a binary way. Don't create your own frameworks or your own templates or whatever. I mean, they're called microservices for a reason, right? They're probably, small or small enough. So it doesn't really make sense to abstract it. Reason is still unwanted coupling, right? Even if you create this, abstraction, you have some form of coupling between services. And these services are created to be totally independent from each other, right? So compared to SOA was all about reuse. Microservices are not about reuse. Microservices are about addressing business agility instead. So microservices are small for a reason, because they're easy to change, and they will change over time, and at some point you'll probably throw them away, right? So microservices are not for reuse. SOA services were for reuse. Microservices are for business agility. So don't share stuff. If you really, really want to avoid the typing, then just copy a single source file from project to project in order to get the jump start, right? But that's about it. They are totally independent from each other, so don't share stuff between services which don't need to be shared and only cause unwanted coupling. So in general, you want to have some conventions over abstractions, right? Instead of doing abstractions, just have a couple of conventions, right? Just let common sense rule instead of, abstract everything away in code. And the same thing goes for technology stacks. So one of the maybe advantages, or for others disadvantages, of doing microservices is that you are now free to select a fit-for-purpose technology stack, right? That's one of the benefits that you often hear, which basically means that you could choose another technology stack for about every service out there in your landscape. Now, if you look at the successful implementations of microservices so far, it's not that Netflix, for example, create all those 800-900 microservices or even more that they have now, each and every one with a different technology stack, right? That will become a maintenance nightmare pretty soon. Although you have this fit-for-purpose tendency, so if there is a service which really, really benefits from an alternative tech approach, right, you're free to do it, right? But on the other hand, if you are a Java shop right now, you're probably proficient in Java, so, I mean, the convention could be that you choose Java for services, And only in specific situations you reach out to other technology stacks, right? Just, let common sense rule. All right. Now, at this point in the presentation, I have to mention Conway's law, because every self-respecting microservices talk mentions Conway at least once. So here's the obligatory reference. And there's a definition, so organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And this was spotted by Melvin Conway, somewhere in the 60s, or 1968 to be precise. So what Melvin Conway actually perceived was that if you have applications or parts of applications that needed to communicate with each other, right, there needed to be organizational structures behind these applications or part of these applications, so that you could have people talking to other people in order to produce these communication structures, right? And so what it actually means, converted into microservices speak, is that you have to make sure that the organization is compatible with the architecture, and also the other way around. Your architecture is compatible with the organization, right? If your architecture does not reflect the way that your organization is going to be structured, or is restructured, then you're going to have a hard time. Because if you make up services which are not backed by someone who feels like he is the owner of that service in the organization, you have no one to figure out with how to make a deal between services, right? How to do the contract and how to communicate between services. So your architecture needs to resemble the organizational structure and the other way around, and that is very important. It also means, and this is just another shout out to DevOps, that your team really has to be cross-functional, right? Everyone that needs to be involved in a team should be part of the team, right? Everyone you need to, from the ID up until the production software, everyone needs to be in the team. And the team needs to be empowered and committed to keeping this stuff into production and maintaining it. And actually, well, it might seem like an open door, but this is actually really hard to do in practice. Once again, just with agile transformation, right, it takes a while for organizational changes to really settle, right? It takes a while to actually convince some people in the organization that you really need to do this in order to make it work. And once again, the business model and business agility should be leading here, and it's not like a technology party. All right, now going back to the old days of SOA, I tend to use this diagram a lot in discussions with customers. So this relates to SOA, and what this diagram actually shows is that in my view, if you want to do a service-oriented transformation, there is a number of levels that you have to go through. So for example, you start at the bottom, and like every programmer, you start counting with 0, right? So you are level 0, and you are implementing, some individual services or web services. And that's how you start your service orientation. It starts very small somewhere in the organization. And at some point, when this matures a bit, you're ready to transition to the next level. And the next level means there will be more process, there will be other tools involved, and there will be new stuff. And this is something that is a growth model. This is something where you can't cut corners, right? So the top right-hand corner of this diagram is what you can call SOA utopia. And by the way, I don't think anyone ever reached that, by the way. But that's not a story. But you have to go through these levels one by one, right? So your level of SOA adoption is somewhere along this curve. And I think what goes for SOA also goes for microservices. You can't cut corners. So in the case of SOA, when vendors came out with these ESB products, right? Then when companies or customers started to buy these products, they wanted to launch themselves into SOA utopia by buying a product. And that clearly didn't work out, right? So they tried to skip level 0 and 1 and immediately go to level 2 by just buying a product. But it doesn't really work that way. It's an organical model which you need to give some time, right? And I think there needs to be something similar for microservices as well. It's something that you start out small and then eventually it will grow into something more, right? All right. So that was round 1. I think we survived. Right? We've seen the struggles. It was a bit of a struggle every now and then. Got a couple punches, but we're still alive. And we're also still in red pill world. And the thing is that even if we thought about all the stuff that I just talked about, and you do everything right, there will still be blood. And there will be blood because in a distributed architecture, failure will always happen. There are so many moving parts involved, that stuff will break. And it will break at the most inconvenient moment, and stuff will break that you never thought that could break, So in order to deal with this is the final piece of the puzzle, I guess, in completely accepting the red pill, is that we should try and design for failure. Or we should design for failure. We should make our services resilient. And this is because now that we've scattered the logic across the landscape, we do lots and lots of remoting. And for some reason, people tend to think that remoting nowadays is cheap and that the network will never fail. Unfortunately, that's not the case, So when you do this on a little bit of a bigger scale, your services will be available at some point, will be unavailable at some point, or there will be a little bit of lagging, Some services will start to lag, and there will be all sorts of overhead going on, and this is when everything start to shake, Now the way to deal with this is first off accept that failure is absolutely normal in this kind of architecture, Embrace it. Failure will happen all the time. So make sure you have a plan A, and if plan A fails, there's still plan B, and then even in plan B, you got to take into account that plan B can fail as well. So you also need to have a plan C, Now, of course, plan C will fail eventually as well, and that's where you have like a graceful degradation. So that's when you are ready to have like a resilient architecture. Now, if failure happens, there's one thing that you should not do, and that's cry for human intervention all the time. Because it's, as soon as a service call fails and you start screaming for attention, then you will have failure written all over your landscape, and that will get you into trouble. So accept that failure is normal, Do your exception handling, but don't cry for human intervention, It should not be a big deal. If you think there is something wrong, you have to fail rather sooner than later. So if something is out of the ordinary, you smell something, You have to suspect failure immediately. Because if you fail fast, it will give you some leeway to try another route, to try plan B or to try plan C eventually, You got to think in terms of performance as well. So don't wait for all kinds of network timeouts to happen. In fact, most of these timeouts, they have ridiculous default settings of minutes, So that means you will detect failure after minutes, and that means that during those minutes, failure will build up in your landscape and it will be a big mess. So as soon as you think something is off, it probably is off, so you go into plan B. Now, there's a number of easy tricks that you can do in order to be more stable and more ready for failures. And some of them are really cheap things, like for example horizontal clustering. So instead of just pushing one service out, you have like 10 instances of the same service. So if one of the instances fails, there are still 9 others which can service requests. Of course, if there is a structural failure in your service, then the 9 others will probably go down as well at some point, But this could get you out of trouble for a while. So horizontal clustering is a way that is used a lot in microservices architectures. Then there's more sophisticated stuff, like for example, resilience patterns that you have. And there's a number of well-known ones, like the circuit breaker or bulkheads that you can read up on, and there's even frameworks implementing those things for you. And then there's also, other, sometimes just keep it simple things, like caching, If you think about Amazon, they have caching all over the place, obviously. And then also, simple things like we do as humans as well. If something fails the first time, just retry it, That sometimes that might be a good option as well. And then you could resort to messaging and stuff. And there's all sorts of things that you can use in order to make your architecture more resilient. Don't overdo it. So from messaging comes ESB eventually, So, and microservices tend not to like ESBs, right? Microservices tend to like the intelligence in the service and not in the pipe, right? So, yeah, just realize that this is complicated stuff. And really creating a resilient service or a resilient service landscape is not something that comes with just including a single library with all of your services. So yes, there's stuff out there, but well, you can't just throw Hystrix in the mix and say, well, okay, so now everything is resilient. All right. So since you have only 5 minutes left, some takeaways. If you really think it through, and you think about the benefits of microservices, then you see it's all about structuring your systems differently. It is about modularity. It's about adding modularity on the architectural level. It mainly is about separation of concerns, right? So you have separate concerns in the architectural landscape, functionally or non-functionally, and you just separate them. And because you separate them, they have different life cycles, and you can change them without breaking other stuff. It's also about doing one thing and one thing well, right? The Unix principle, or in this case, the single responsibility principle. And the main bottom line thing is that you address business agility through technology, not the other way around, right? So you don't do this because you like Docker a lot. You do this because you have a changing business model and you really need to adapt to it. So you need to keep time to market short and you need to satisfy your users as soon as possible. And that's why you resort to this kind of architecture. Now, all of those things are not bad things, but they're also not things that come for free, right? So everything comes at a price. And so, once again, there's no such thing as a free lunch, right? And that means that there's a couple of easy things, think about the initial investments, and there's a couple of things which are harder to do. Think about Conway's law, for example, right? Aligning the architecture to the organization. That's one of the hardest things to do in doing microservices, in adopting it. And whatever some of the other microservices talks are trying to convince you of, it is not about just doing a framework, right? So if you go into one of the other talks and they say, well, we have this nice framework, Spring Boot, right? Right? Just building your software using that framework does not yield you true microservices. Yes, it yields you modular components, maybe, small components, and they have a lot of really cool stuff in there. But there's way more to doing microservices than just selecting a framework and building some code. Now, since this is just a relatively young architectural style, right, you should keep on educating yourself, because the true war stories are still about to see the light of day, right? You heard a couple of success stories, and maybe you heard a couple of failures as well, because there's a number of interesting cases of that as well, well documented, right? So keep on learning from other customers and other companies going through this journey, right? What you especially should not do is listen to a single version of a vendor story, right? Because vendors just care about, selling you their terrible products and about locking you in. So you should be wary of the vendors, right? Think about what happened to SOA. Now, of course, this is also really easy to say, but it's hard to do in practice. Make sure you have your rational thought process trump the microservices hype. And whatever you read on Twitter or in blogs, right, it doesn't come for free. And now maybe there's, maybe Steve Jobs style, I should end with, and one more thing. So there you have it. Actually, maybe this is the slide with the most important point of the talk. Because we are not all Netflix or Amazon or Google or what have you, right? Just like with the big data hype and with the web skill hypes, right? People really try and pretend that they are exactly the same like Netflix or Amazon. But we mostly live on an entirely different skill. And the reason I'm saying this is that as soon as you go their solution, right? As soon as you go their way, you will automatically get all of their problems for free. Even if you have just a handful of services, right? You get all of their infrastructural problems for free that come as part of the solution. So with that caution, I would like to thank you for your attention. So, tak.